Welcome back, everyone. Still, voice is terrible and broken. Still trying to shake the cigarette habit. But I feel like I'm getting there. Today, we're going to talk about everybody's favorite mathematical operation, division. I know how much you all like fractions. Yay, fractions. Since we can add, subtract, and multiply polynomials, of course we can divide polynomials as well. This is the symbols that we had for that way back in quarter one. F over g of x means f of x divided by g of x, as long as the denominator doesn't equal 0. Right now, we are not concerning ourselves with that. Right now, we're literally just dividing the polynomials. So we'll start off with a nice little Mickey Mouse layup question here. That's not technically even polynomial division, because this is a monomial. And yes, this is division because that's got a negative exponent. And if you remember, anything with a negative exponent actually moves to the other side of its own fraction bar. So let's write this out. We've got the 3x to the fourth y squared, 36x to the fourth y squared, excuse me, minus 24x cubed y cubed plus 48x squared y fourth, all being divided by this thing. So yeah, we'll let its negative exponent send it to the bottom so its exponent can turn positive. And there's no reason to write a set of parentheses with a power of 1 because, well, it doesn't do anything. There. The thing on top has 3 terms, and those terms are held together with pluses and minuses. Because of that, we can write this as 3 separate fractions, where all 3 fractions are held together with pluses and minuses, and they all have this denominator. There's one of them. And then minus the next term on top, 24x to the third y to the third, divided by 12x squared y. And plus the third term divided by, it's going to get me 48x squared y to the fourth over 12x squared y. And that's it for that. All 3 of these fractions reduce. So we reduce them all independent of one another, and we see what we end up with. The first one, 36 divided by 12, well, that's 3. Here, I'm dividing x's. When you divide 2 numbers with the same base, you subtract their exponents. 4 minus 2 is positive 2. And here, I'm dividing y's. When you divide 2 numbers with the same base, you subtract their exponents. This exponent is a 2, this exponent's a 1. When you subtract, you just get a 1. There you go. No more fraction. Minus. Divide. 24 over 12 is 2. Dividing x's, so subtract the exponents. 3 minus 2 is 1, so x to the 1. Dividing, so subtract exponents. 3 minus 1 is 2. Y squared. And lastly, plus 48 divided by 12 is 4. X squared divided by x squared, well, those just cancel out. Poof, gone. And y to the fourth divided by y, 4 minus 1 is 3, y to the third. And that's finished. That's it. That's not even really polynomial division. That's reducing fractions. So far, so good? Feeling okay so far? Not bad, right? Okay. Before we can get into polynomial long division, I have to remind you how long division works. I'm waiting. I see. Still writing? You good? Okay. I have to remind you how long division works. So here I cooked up a number, 2, 3, 4, 5, 6. I'm dividing it by 7. Just for fun, okay? By the way, I told them I would give them credit for this. Allie Meyer looked it up for me today. This symbol is called an obelus. Obelus. I'm not sure how to say the word obelus, if you cared. I didn't, but she told me. So I was like, okay, hey, I'm a nerd, so obelus. And the division bar, come on, black pen. The division bar, that I'll finish writing in just a second. This thing is called a vinculum, if you care. I'm a nerd, so I cared. You don't need to know those words. I'm not going to test you on them. I'm sure. Okay, so long division. Let's see how this works. Remind you of some 4th or 5th grade math, whenever it was that they taught you how to do this. Can I divide 2 by 7? Nope. Can I divide 23 by 7? I can. I mean, it's not perfect, but I can. What would I have to multiply a 7 by to get close to a 23? 3. So we're going to put a 3 right there. We're now going to multiply that 3 and that 7. And what it's going to give me, sorry, I'm scratching my arm. What it's going to give me is 21. So it's not 23, but it's close. It's close, right? We got close. What we do at this point is subtract straight down. Remember yesterday when I had you stacking your polynomials vertically and I said I put my minus sign between the two and stuff like that? It's because I was preparing you to do this. When you subtract straight down, what you get is that we were off by 2. At this point, some of you might have been trained to drop down just the 4. Some of you might have been trained to drop down the 4, 5, and 6. It actually doesn't matter. Do whichever one you're comfortable with and stick to it. I was taught to bring down one thing unless you need more, and I don't need more, so I'm going to bring down the one thing. Now, we're not even looking here anymore. Now we're paying attention to the 24. We're trying to make a 7 become a 24. What do I have to multiply 7 by to get close to 24? 3 again. Yeah, all right, so I'll put a 3 up there again. We now took this number, and we multiply it to the 7. It gets us at 21 again. So yeah, again, we weren't perfect, but we got close. We got close. Divide, or subtract, excuse me. Gets me a 3. Can drop down this 5 or the 56, whichever you were taught to do, whichever you prefer to do. I like to write less. So, huh? What do I have to do to make a 7 become close to a 35? What do I multiply by? 5. And you know what? That's actually perfectly 35. So when you go to subtract, you get a 0. Now, lastly, we could drop this 6 down, and I get to ask you, how many times will a 7 fit into a 6? 0 times. That means there's a remainder of 6. Now, you might have been taught to do like R6, but eventually you used fractions. And it would have been written like that. 3,350 and 6 divided by 7. Because you cannot divide this 6 by the 7, the division symbol gets stuck there. But notice when I said this result, I said the word and. 3,350 and 6 over 7. In mathematics, and is a plus sign. So how do you feel about your long division review crash course? You okay with it? It's all right? Great. I'm glad you love it, Daniel Q. He says he loves it. He says he's going to do long division in his sleep. Nerd. So before I move on to actually polynomial long division, I want to talk about vocabulary because it's important. Because I'm going to use these words while I'm teaching the material. The thing that we are trying to divide up is called the dividend. The thing that is doing the dividing is called the divisor. The number 3350 is the quotient, and 6 is the remainder. And it's important that we use words like dividend, divisor, quotient, and remainder when we're discussing this stuff. Okay? Okay. If you can handle long division with numbers, you can handle long division with polynomials because they work exactly the same way. Exactly the same way. I'll draw my division bar in a moment. Throw my vinculum on there. Oh, did I tell you who looked up the name vinculum? No, obelisk was Ali Meyer, and vinculum was Melissa Apollonio. Is that how you say her last name? Melissa Apollonio? I think I said it right. Okay. I told them I'd give them credit in the video. Okay, here we go. When we were looking at these numbers, we couldn't use the 2 here because we couldn't make the 7 become a 2. But we could make this 7 almost become this 23. And that's why we looked there first. So we're looking at the fronts of things. Treat this the same way. Our job is not to make this match this perfectly through multiplication, just like we weren't getting matched this perfectly through multiplication until maybe the very end. We were getting close. Our job is to try to get close. So we're trying to multiply this by something so that it'll look like this. What do we have to multiply an x by to get a 2x to the third? A 2x squared would do it. If we multiply this x by 2x squared, we will get a 2x cubed. And we will have made them look very similar. So we multiply by a 2x squared. I'm going to write it above this negative 3x squared because I want my like terms to line up. And believe it or not, you were doing the same thing here. You just didn't know it. You were making your like terms line up. Now, just like I took up here, I took my quotient, the number that was a part of my quotient, and I multiplied it to the divisor to figure out what's going on down here. I'm going to do the same thing here. I take this 2x squared, and I multiply it to my divisor because I'm trying to figure how far off I am. So multiply 2x squared to the divisor. 2x squared times x is 2x to the third. 2x squared times negative 3 is negative 6x squared. And just like before, I will need to subtract to figure out how far off I was. Before I subtract, Brock, what's up?
How do you do the 2x squared?
The 2x squared is because we're trying to figure out what do we have to multiply this x by to match this 2x to the third. We have to multiply by 2. And we need 2 more x's. Okay? Yes, Ilya?
Was it only coincidence that the negative 6x squared lined up with the 3x squared?
You wanted to know if the like terms lining up was a coincidence?
Yes.
No. It was not a coincidence. But we'll get to it in a bit. Okay? Now, we subtract straight down. Just like yesterday, the hardest part about this is going to be your double negatives. Watch out for them, please. Let's see how far off we were in our division here. Let's see, 2 minus 2, like terms lined up, so I don't have to say the x's. 0, good. It means we were really close. Negative 3 minus negative 6. Anytime you say minus negative, remember, that's plus. So we actually have negative 3 plus 6. I have a 3x squared. Either bring down just the minus 5x or minus 5x minus 10, Whatever you were taught to do that you're comfortable with, that's up to you. I'm a fan of only bringing down the next thing unless I need more. And right now, I don't think I need more. And then once again, just like we did here, we were like, okay, what do I have to do to make this 7 becomes the 24 now? I'm asking, what do I need to multiply by to make this x minus 3 become something very similar to this 3x squared minus 5x? And the answer to that is whatever makes the front match. What do I need to multiply x by to get 3x squared? A 3 and an x. If I multiply this by a 3x, I will get 3x squared. I take that 3x, I distribute it to both parts of the divisor. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Just like before, we need to subtract straight down to see how far off we were. Daniel Q, is that question face or normal face? Normal face. Okay, I'll remember that. 3 minus 3 is 0. Good, we did this right because the fronts cancel out. Negative 5 minus negative 9, that's negative 5 plus 9, 4x. Lastly, drop down the minus 10. Now we're asking ourselves, what would I need to multiply by so that this x looked like this 4x? Multiply by 4. Take that 4, distribute it to the divisor. You'll get 4x minus 12. And we subtract straight down. 4x minus 4x, good. They canceled each other out. If they hadn't canceled each other out, that means the number you chose up here or the term you chose was wrong. Go back. You needed more. They have to cancel. Negative 10 minus negative 12, that's negative 10 plus 12. That's 2. Can I multiply x by something to get a 2? No, I can't. I could divide x by something to get a 2. You know why? Because this is technically degree 0. Imagine there's an x to the 0 sitting next to it. This is degree 1. Because down here has a degree that is less than my divisor, I'm finished. That's my remainder. And just like I did with the number long division up here, it's plus remainder over divisor. That is polynomial long division. If you have questions about any part of it at all, please say something to me. Ask me some questions if you need to. Yes, Barry.
You said that you could divide in order for x to get 2. What do you mean by that?
If you divided x by 1/2 x,
Okay, so that would be times 2x.
it'd be times 2, but the x's would cancel. But it's not something that we can do. So you'd be multiplying by 2 over x. Hey, look, there's basically a 2 over x. You see? So now, if the degree is smaller than the divisor's degree, you're finished. Okay? Other questions for me? No? All right. Then we'll flip it over and we'll do it again. Let's see. I like my color palette today, so I'm going to go back to the same colors. Get my divisor and my dividend in purple. Throw my vinculum on there. And now we're going to go through it again. Again, we're trying to make it get as close to what we see here as possible through multiplication. And the way we pull that off is by making the front match. You have to multiply x by something, and the result needs to be a 2x to the third. What do I need? 2x squared. I'm going to put that here so that my like terms line up. I now take my 2x squared and I distribute it to my divisor. It's going to get me 2x to the third minus 6x squared. It was close, but it really wasn't perfect. So we'll subtract straight down. 2 minus 2 is 0. Luckily, the like terms are lining up. Negative 3 minus negative 6. That's negative 3 plus 6. Once again, negative 3 plus 6 is positive 3. Do you guys mind if I don't draw the blue arrows? If I just drop something down? Are we all comfortable with that? All right. Because I really do want to write as little as possible. I think I can speak for everybody when I say writing less is better. Now I need to multiply so that this x becomes this 3x squared. What do I have to multiply by?
3x.
Got to multiply by 3x. I'm going to take this 3x and I'm going to distribute it to my divisor. I get 3x squared minus 9x. It wasn't a perfect match, but it was pretty close. We used subtraction to see how far off we were. Negative 5 minus negative 9, because the 3's have canceled already. That's negative 5 plus 9, positive 4. Drop down the minus 12. What do I have to multiply this x by to get this 4x? 4. Take the 4, distribute it to the divisor. Anything minus itself is 0. This one had no remainder. The one on the previous page did have a remainder. Did any of you notice that it was basically the same polynomial? Basically the same, right? What was different about this one? What'd you see, Parker?
The negative 12.
The negative 12, what was it before?
Negative 10.
Negative 10, how far off was it? 2, what was my remainder?
2 over x minus 3.
Remainder was 2. How about that? What I did was, I just took 2 away from this one since I had 2 too much down here to create one that didn't have a remainder. So why did I do that? Well, because I need you to know that not every division gets you a remainder. Now I want to go back to some basic mathematics and ask you some questions. Anytime you divide a number by another number, why would you end up with a remainder? Under what circumstances do you get a remainder when you divide? You say it's not divisible by. So that means, what's an academic vocabulary word that you could use that says this cannot be divided evenly by this? Use a word that describes something. They're real. Look at them. No, you're working too hard. We're talking about elementary mathematics. What'd she say back there? No, it's not irrational. I mean, no. No, we're working way too hard, guys. Can I divide 12 by 5? Without a remainder? No. Can I divide 12 by 6 without a remainder? Yes, I can. Yeah, 12 by 6. So why can I divide 12 by 6 but not 12 by 5? There's the word. What was it? Because 6 is a factor of 12. 5 is not. You learned the word factor in elementary school. 7 is not a factor of this. And the same kind of words, this number is not a multiple of 7. So this number is not a multiple of 7. 7 is not a factor of this number. So why did I bring that up? Oh, look, a polynomial. I attempted to divide by x minus 3. I got a remainder. Do you know what that tells me? That tells me x minus 3 is not one of the factors of this cubic. And when we factored quadratics. Remember we broke them into their sets of parentheses? This remainder tells me this wouldn't be one of the sets of parentheses if I could factor it. But here I got no remainder. That means when you break this thing down into all of its sets of parentheses, that's one of them. And we're thinking ahead to next chapter already. When we were dealing with our quadratics, there were two different reasons why we factored them. Anybody want to tell me what those two reasons were? Or want to tell me one of the two reasons why we factor quadratics, Thomas? One of the reasons why is to find a solution. But we just talked about solutions. What's another word for a solution? A zero, also known as a x-intercept. So what would be the other reason why we would want to factor something? Not just solve it, but also? But why do you want the x-intercepts? To graph it. Next chapter is all about graphing. So if I wanted you to graph this polynomial, it would be beneficial if you had a method for finding factors, wouldn't it? Because when there's no remainder, you found a factor. And if I wanted to know where else this thing has solutions, hey, look, a quadratic. I could solve that any way that I know how to solve quadratics. I'll just go ahead and tell you this has no real solutions. So this graph only crosses the x-axis once at x equals 3, which is its only solution, x equals 3. Its only real solution, x equals 3. But anyway, that's next chapter. Let's divide again. I have a question. Man, fingers crossed, fingers crossed. Do I have anybody in the room that tried to move ahead of me and already attempted this example? A couple of you did. Did you get stuck? Yeah. Both of you got stuck, huh? Huh? Brody, tell me, when you tried to divide this, what happened? Why did you get stumped? I'm so glad somebody actually worked ahead. Why did you get stuck? Don't try to be fancy about it. Tell me what stopped you from continuing. Ask Ilya to help you, because he's kind of already touched on it.
You get -2 and you minus, and then below the -2 you get x squared.
Oh, there's an x squared underneath a 2. Ilya, you asked me a question earlier. What was that question? Do you remember?
What if there was space in between the
You asked me, was it a coincidence that the like terms lined up? And I told you, no, it wasn't. You see, these two gentlemen tried to work ahead, and I commend that. And I'm glad that you did. But when they worked ahead, they found an example where the like terms didn't line up. Now let's talk about why that happened. Do you remember yesterday when I told you about combining your like terms? If there was a missing term, you could just leave it blank, or you could use a 0 term, right? Okay. Within this polynomial, it is missing x squared, and it's missing x. I like to say this thing is a gap-toothed smile. It's got some teeth missing. Not the edges. We don't ever care about the edges. No one knows if you're missing a molar. But if you're missing a tooth in the middle, we're going to see it. This thing is missing x squared and x. And because of that, we need to hold that position open with an x squared and an x. When doing long division, you must not ever have gaps in your polynomials. And if you do, your like terms will not line up. And now you know why you ran into that issue. But I'm glad you tried, so I had someone to ask, rather than just tell you that that's what happens. All right, let's get to it. This time I'm dividing by a quadratic, whatever. Then we have this plus 0x squared, a plus 0x. Now this thing counts down from power of 4 to power of nothing with no gaps in its teeth. Draw my vinculum. There it is. And now when you do this, your like terms will always line up. So when you're working on your practice or you're working on a test, if your like terms didn't line up, you had a gap in the smile. Go back and put a 0 there, a 0 term. 0x squared, 0x, both of those things equal 0. So I haven't changed anything. Okay, that was all that was different about this question. What do I need to multiply this 2x squared by to get this 2x to the 4th? Just x squared. And that lines up way back here. Also, when you were trying to fill out your top, where did you put this x squared? So you just put it between somewhere because it didn't have a home. You see? Now it has a home, right above the 0x squared. So take this x squared, multiply it to your entire divisor. You will get 2x to the 4th plus 2x to the 3rd. No, just x to the 3rd. My apologies, just x to the 3rd. It's x squared times x. And x squared times 1 is 1x squared. We're close because the front terms cancel when I subtract. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. I'm going to drop down the next term. And now we do the exact same trick, where we just try to make the fronts match. We ask ourselves what we have to multiply this 2x squared by to get this negative 2x to the 3rd. A negative, and one more x will do it. Take that negative x, distribute it to the entire divisor. Negative x times 2x squared. It's supposed to be green. Negative x times positive x is negative x squared. That's interesting. Those match. Both of them match. And negative x times 1 is negative x. There. Anything minus itself is 0. 0x to the 3rd. 0x squared. Interesting. 0 minus negative 1. That's positive 1x. What is the degree of this? You can say it louder. 1. What's the degree of my divisor? 2. That's less. Because the degree down here is less than the degree of the divisor, I'm finished. That's my remainder. And there it is. And we only have one more example to get through today. So I ask you again, is there anything you'd like to ask me? Anything I can help you with? Anything that I could do to make this better, more understandable? All right. Then we'll do one more. Remember, we don't like gaps in our smile. So count down. 4 is missing. Okay. Okay. Gap tooth. 5, 4, 3, 2. Okay. It's also missing X. 5, 4, 3, 2, 1, none. Good. Whew. Now let's check our divisor. 3, oof. Missing X squared. 3, 2, 1, none. Okay, there. We identified all the gaps in the smiles. Because you can't have missing terms in the dividend or the divisor. If you do, your like terms will not line up. And we want our like terms to line up. And because I ran out of horizontal space, if there's a remainder, I'm not going to be able to fit it on my page. I'll have to write my final answer over here if that occurs. You might have noticed how much space I left you in the homework for each question. You might have also noticed that I gave you the answers on the homework. So I'm not going to be posting an answer key because the answers are on the homework. Okay? What's that? I don't know. You tell me. Okay, let's go ahead and do it. So we're trying to make this 2x to the third become this 2x to the fifth. What do I have to multiply by? Just x squared. Yep. Well, that's way over here. Let's take this x squared and distribute it to our divisor. 2x to the fifth plus 0x to the fourth plus x to the third plus x squared. All right. 2 minus 2 is 0. 0 minus 0 is 0. Oh, okay. Negative 1 minus 1. That's not 0. That's negative 2. X squared minus x squared. That's 0. But I can't have a gap, right? So I'll have to literally say 0x squared. And I could drop down this 0x now, but here's the thing. My divisor has 4 pieces. I need this to have 4 pieces. So I'll bring down the negative 2 also. And now they both have 4 pieces. There. So what do I have to multiply this 2x to the third by to get this negative 2x to the third? Oh, negative 1. That's it. Just negative 1. Distribute the negative 1 to the divisor. Negative 2x to the third. Those match. Technically, plus 0x squared. They match, but they're both zeros. Minus x minus 1. Anything minus itself is 0. So negative 2 minus negative 2, 0. 0 minus 0, 0. 0 minus negative 1. 0 minus negative 1 is positive 1. Negative 2 minus negative 1, that's negative 2 plus 1. The degree of my divisor is 2. The degree of what's down here is 1. That means I'm finished dividing. That is my remainder. And since I'm out of horizontal space, I'll write the answer over here. It's going to give me x squared minus 1 plus x minus 1 over 2x to the third plus x plus 1. And that is it. Do you have any questions for me about the long division process, remainders, gaps in the polynomials, any of that? Anything at all before I call the video finito? No? Ah, thank you, nerds.